All right, here is your free response question of the day. So, in this question, this is the real question that was used in 2017, free response question number 1. So, it was the first free response question they had, and you're allowed to use a calculator if you need it. So, let's look at what's given here. So, we're given a table of values. I really look at the units here. So, the first is feet. Here is square feet. So, it's not a rate. So, to me, first of all, I'm looking at that. So A, probably area to do with square feet, but not like square feet per minute or something like that. So it's just a unit, square feet. A tank has a height of 10 feet. The area of horizontal cross sections of the tank at height h feet is given by that function where A at h is measured in square feet. The function A is continuous and decreases as h increases. So you have a tank and it's wider at the bottom, and as it comes up to the top, it gets narrower and narrower as it comes up to the top, just to get a visual of that. And then they say, okay, at the very beginning, the bottom of the tank is like, what's the square feet of the bottom? And then if you take a horizontal cross section as you go up 2 or 5 or at the very top, you can see the width, the area of the cross section as you go up, and then it's getting smaller and smaller. So it's important, it's continuous and decreasing. So part A, what is it asking you to do with the numbers? So use that left Riemann sum with 3 subintervals as indicated in the data to approximate the volume of the tank and then indicate the units of measurement. So I could actually do that right here where it says A. So to do that, what we're really doing is going from 0 to 10. So that's what it's really asking us to do. We're using a left Riemann sum. They are not the same width. So the first width is 0 to 2, so that's 2. And then left means we're going to use 50.3. Again, 2 to 5 is 3, and a left Riemann sum is 14.4. And then 5 to 10 is 5, and then a left Riemann sum is 6.5. You do not need to simplify that. That would be a great answer. But if you did use your calculator and simplify it, it would be 176.3. And then what would the units be if you're doing that? So because we're finding volume, the unit would not be square feet, but feet cubed because of the word volume. So because we're finding volume, the unit would be feet cubed. So the approximate volume of that tank is 176 cubic feet. And we're done. Part B, does the approximation an overestimate or an underestimate? And explain your reason. So when we do a Riemann sum, it's either going to be an over or underestimate. How would we know? So the first thing we'd look at is it increasing or decreasing. And I like to draw a picture of it. So it's decreasing. And then if I draw a decreasing line of some sort in this, okay, this is a left Riemann sum. If you would draw a left Riemann sum where the left of the rectangle is touching the function, was that an over or underestimate of what you see? Are those rectangles going over the top or are they underneath? And so you can see it's an overestimate. So we're going to write that down. It is an overestimate. And why? And it's because A at h is decreasing. That's a big word. With decreasing with a left Riemann sum. So they were looking for those two words, decreasing and left Riemann sum, to explain why it's an overestimate. All right, part C. The area in square feet of the horizontal cross sections at height h feet is modeled by this function. So we have a function that models what the horizontal cross-section area is. Based on this model, find the volume of the tank and indicate. So if I'm going to use a cross-section of known cross-sections, so this is part C, that's an integration, and we're integrating from 0 to 10, and whatever the cross-section would be is what we're looking for. So if the cross section was squares or triangles, we'd use that formula. In this case, we don't have a formula of a square or a triangle or a rectangle. It just gives us what the formula is. So here's the unique formula for the area of a cross section. So we just use what's given. So we don't have a common shape. Instead, whatever that shape is, we're given a function that describes the cross section area. So we just use it. So we're going to type that in. And that's it. So from 0 to 10, type that in to your calculator. I'll do it too. So we are integrating from 0 to 10. I'm going to do a fraction. So I'm going to do a fraction line right away. 50.3. The denominator is e to the 0.2. H is fine. And then move the cursor over, and then it's plus h, not in the exponent. And then dh, and then control, enter. And you get about 101.325. And again, what would the unit be here? Again, it's in feet cubed because it's volume. Part D. Water is being pumped into the tank. When the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. So you're just told that dH by dt equals 0.26, and that the height h we're given is 5. That's what we know so far. Using the model from part C, so that's the equation, find the rate at which the volume of water is changing with respect to time. All right, so what's the setup going to be first of all? So volume is this, integrating from 0 to whatever the height is. Now we know the height is 5, but that is not a constant. So we're going to say to a variable, and that variable is h. So from 0 to h, actually we'll use different variables here because when you actually take the derivative, it's going to be that fundamental theorem of calculus where they'll undo each other and just leave you with f at h. But there's the model to find the volume at any height. So if I wanted to find the height at 1, you plug in 1 for height. If you want to find the volume and the height is 5, you plug in 5, and so on. So there's the model, the equation that describes the volume. Now to take the derivative with respect to time, it would be dv by dt. So the derivative of v is 1, but we need to do it with respect to time. The derivative of this, they undo each other. You just plug that in, the fundamental theorem of calculus. But we need dh by dt as a hook on to know that we're not taking the derivative with respect to h, but with respect to time. So it needs that hook dh by dt. The question is, find the rate at which the volume. So we're finding this is what we're looking for. Now we can actually plug in the number we're asked for. So the volume when h equals 5, what would that look like? So we're going to plug in 5 for h, and then dh by dt was 0.26. And now we're just going to use our calculator to calculate it, and that's it. So let's type this in. So I'm going to use the equation again. I'm going to start with a fraction, and I'm going to go 50.3, and then it's e to the exponent 0.2 times 5. Move it, and again it's plus 5. So take out the h and put in 5, and then move the cursor again and go times 0.26, and then go control enter, and you get 1.694. That's what we're looking for. Now, what would the unit be there? 1.694, and again, it's volume, so that's feet cubed, but it's a rate, so it's feet cubed per, in the question, minute. And you're done. All right, you did the free response question of the day. I'm so proud of you. Mr. G Math over and out, and until next time.